everyone. For this lesson, I'll show you the direct variation equation. Let's say you have the equation y equals kx, where k is not equal to 0. So k cannot be 0. Whenever you have a situation like this, an equation written in this form, y equals kx, where k is not equal to 0, this represents a direct variation between y and x. Okay, so this is a direct variation equation, y equals kx, and the letter k is known as the constant of variation. Okay, let's say you have this example here. 7y is equal to 5x, and I want to check to see if that is a direct variation equation. Alright, to do that, just solve for y. Right? So let me rewrite that one more time. 7y equals 5x. So I'm going to divide both sides by 7. Right? So now I'm left with y, right, because it's 7 here and this 7 here, they canceled. So y is equal to 5 over 7x. You can write it like that. And this is in the form of y equals kx. Right? So this is a direct variation equation, right? Now let's say you have, let's take a look at this example here, example 2. Let's say you have 2y plus 5x is equal to 3. And again, we want to check to see if this equation is a direct variation equation. So again, we're going to solve for y, right? So let me rewrite that one more time. Right, so the first step, let me change the color here, is minus the 5x, right? So you're left with 2y, and then this one and this one, they cancel, and this is just negative 5x plus 3. And the next step is to divide this by 2, divide this by 2, and divide this by 2, and that reduces to just y equals negative 5 over 2x, you can write it like that, plus 3/2. Okay, and this is not in the form of y equals kx, right? So this one is not a direct variation equation, right? So this is a no. The first one was a yes. Okay, and we're done with these examples, and we're happy. Okay, now let's say I tell you that y varies directly with x, right? So that's given to you, okay? Y varies directly with x, and I also tell you that y is equal to 35 and x is equal to 5, and I want you to come up with the equation for the direct variation, right? In order to do that, we're going to use the form y equals kx, okay, and we plug in the values for y and x. So here y is 35, right? So let's plug that in here, 35, done, right? And then x is 5, right? So replace x with 5, right? And equal sign, and there's a k here. So we want to get the multiplication, and we want to get k. So divide both sides by 5, right? So I'm going to divide this by 5 and divide this side by 5. Right? Remember, you do one side, you have to do the exact same thing to the other side. And so this just reduces to just k, and we're happy with that. And here it's just 3505. That just comes out to 7. So k is 7. So we're going to use that information, right, to write out our direct variation equation. So y equals kx, but we just found k to be 7, so let's go back and replace k. And look at that. This is our equation, right, that relates y and x. And we're done. Alright, let's say your weight on Mars. So this is the planet Mars. Varies directly with your weight on Earth, right? So varies directly, right? So your weight varies directly. Okay, so let's say my weight on Mars is 53.2 pounds, right? If I were to go, right? So this is me, and put on my spacesuit, right? There it is. Right, so I weigh 53.2 pounds on Mars, and on Earth, it's me again, right? And I only weigh 142 pounds. Okay, but we know that my weight, right, varies directly, right? So I want to write the equation for this relationship, right? So again, I'm going to use the form y equals kx. Okay, my weight on Mars is 53.2, right? So this is the y, right? And my weight on Earth is 140 pounds, so that's my x. Okay, so k we don't know, but we'll find out soon enough. Then this is 140 pounds. Okay, so to get k by itself, I'm just going to divide both sides by 140, right? 140, and if we do this out, k comes, well, this 140 and this 140, they cancel. You're just left with the k, and here if you do it out, you're going to get 0.38. Okay, so once we know what k is, we can go back and rewrite our direct variation equation. Okay, so here y equals kx, keep the y as is, and I'm going to change the k to 0.38 and leave the x there. Alright, so y is my weight on Mars, so I can figure out your weight on Mars if I know your weight on Earth, or what your weight is here. Sorry, so plug that in for x and you can get the corresponding y, right? And this is a direct variation equation to represent that relationship. And we're done. Alright, so let's take a look at the graphs of direct variation equations, right? So if you have k greater than 0, right? So your equation is in the form of y equals kx. We know it's a direct variation equation, and we want to know what that what the graphs look like for it, right? So if k is greater than 0, your graph is going to look something like this. Okay, or your line. Okay, it has to go through 0, 0, which is the origin. It's where the x-axis and your y-axis meet. And so if k is greater than 0, it's going to look something like this. Right? You can have something looks like that. Okay? And if k is less than 0, it's going to go in the opposite direction. It's going to go something like this. Right? Or something like this. Right? You notice that it must pass through the origin, right? The 0, 0. So at the intersection of x and y axis, it's the point 0, 0. Okay? Alright, let's say you have these two t-tables. Right? Call this one A, call this one B, and you have these corresponding numbers here. 210, 315, and 420. And over for B, you have 17, 26, and 520. Alright? And the question is, can we use the t-table to check to see if there's a direct variation? Right? In order to do that, you want to check y over x for each one, right? The ratio y over x, right? So if I do it for 2 and 10, I'm going to get 5, right? So this one's 5 because it's 10 over 2, right? And then do the same thing for 3 and 15. So 15 over 3, y over x, I also get 5. And the same thing for 4 and 20. So 20 over 4, I also get 5, right? So whenever you have a consistent number like this, 5, 5, 5, and it doesn't change when you do y over x, that implies that this is a direct variation. Okay? Now let's try to do that with B, right? So 7 over 1, y over x, right? So we want to check the ratio y over x. So this one is 7, right? This is 7. Do the same thing for 2 and 6. So 6 over 2, that's 3. And do the same thing for 20 over 5. And that comes out to 4. And if you notice, right, this one's a 7. Oh, put a 4 over here. And this one's a 3, and this one's a 4. So they're all different, right? 7 here, 3 here, 4. They're all different. So not the same ratio for all the data pairs, right? So if that's the case, then this is not a direct variation. Okay? And we're done.